Hello, Math 215. So in this video, I want to talk about place value and alternative bases. Now we'll be doing a little bit more with this, but I just want to talk about what place value is and this thing that you've been living with all this time, and what it means and how it works. Now we did talk about Roman numerals, and the thing about Roman numerals is when you write a C in Roman numeral, that always means 100. I mean, sometimes it's subtracting 100, but it always means 100. Well, let's actually say, right, CCC. That means 300 somehow. Now, that's not how our system works. The way our system works is, if I want to write 300, I'm going to use a 3. But 3 doesn't always mean 300. It could mean 3 ones. It could mean 3 tens. It could mean 3 million. It could mean 3 of something. But in order to make it mean 300, I need to put 2 more place values after it. I need to, if it's a 0, I'll put a 0, but it's not always a 0. Pretty much any number after a 3, any 2 numbers after a 3 would make that become a 300. Sometimes we call this promotion. So like the 3 starts out as a 3 ones, but if I put a 0 after it, I promoted it to the tens position. And if I put another 0 after that, I promoted it once again. So you can promote a number by putting it in its place, the proper place value. Also, the 3 can be demoted by putting it into a different place value. Now, the method that's used to describe this, and we're going to talk about not just place value in our base 10, but we're going to talk about alternate bases. The way we usually do this to describe this in a class like this is we make our own place value blocks. And the place value blocks are these, usually they're called base 10 blocks because it's for base 10. This mock-up is for base 5. So you have ones, and you always need ones, no matter what your system is. And then whatever your base is, you make things that big. So 5 ones make a 5, if we're talking base 5. And then 5 fives make a 25, if we're talking base 5 again. So these place value blocks are great. I don't happen to have any of those and with me, and even if I did, I kind of like, at least for adults, to talk about place value with money instead, because there's something about money. We've been, at some point in your life, probably because you earn it, you understand when money is equal and when it's not equal. I mean, students, just adults, understand the equality of money, the equivalencies of different amounts. But I just want to talk about recording this value here. All right, so if I'm using this little tray here, and we're certainly in base 10 because I'm using the tens and hundreds, how would I record this number? Well, I would just record it as 2, 4, 3, and I'm going to go ahead and say base 10, because today only, we never know whether I'm talking base 10 or some other base. Now let's say I wanted to talk about that same number, but in base 5. Well, my model would be changed. I'd have to use different coins. The reason why I'm using different coins, kind of like, back to this, all right? If I'm using base 5, this isn't 10, and this isn't 100. If I'm using base 5, I need 1s, 5s, and 25s. So here it is. This number means this. It means 2 25s, 4 5s, and 3 1s. And one question is, well, how much is that? Well, how much is that in our base? Well, it's 50, 60, 73. So this is equal to 73 base 10. So be prepared to answer questions like that. You just have to understand what it means. Right? If you understand what it means, it's can be a fairly quick calculation in that direction. All right. Now let's do another. Let's do it the other way around. Let's say I said 2, 0, 1. I gave you the number, and let's say in base 5. What number am I talking about? Well, first of all, let's not assume that base 5 is a mistake. Sometimes that's the answer. We just want to say, oh, 2 of these, 0 of these, 1 of these. So in other words, don't be in a hurry to change it. Sometimes we want to just, that's the answer. We want to just understand what it means. But I think if you can change that to 51 base 10, you get it. You understand what that is. Now, let me make a mistake that is very common when you're working with another base. Let's say if I was working with base 10, I could put anywhere from 0 to 9 coins here. But let's say I put 6 coins there. And I said, I'm talking about, well, let's put 2 coins in here just so I could get a number out of it. And I said, I'm thinking of the number 26 base 5. Now, the reason why this is a mistake is when we can exchange 5 ones for a 5, we have to do that. So I'm not allowed to have 6 ones in base 5. As soon as I get 5 of a kind, I've got to trade it in for the next bigger one. So, like I said, it's not I don't want to just leave. I want to fix this, and the fix is it's 3, 1, base 5. In other words, 2 nickels and 6 pennies is equal to 3 nickels and 1 penny, but this would be more the correct way to do it if you're trying to, use change correctly. So if we're trying to use place value correctly, that's what we want to do as well. Now, one of the things that's going to be important to us is this idea of counting, and that kind of touches on this last example, kind of touches on that. If you're counting in base 5, it goes 0, then 1, 2, 3, 4, and we can't say 5. In other words, you're not allowed to write down 0, 1, 2, 3, 4. You can't write down 5. What you're going to write down is 1, 0, because after 4, you get 1 nickel and 0 ones. So in base 5, 1, 0 means a 5 and a 1. Let me keep on counting here, because like I said, counting is probably the most important thing we can do in any base. And after 1, 4, it becomes 2, 0. So I made this thing here. So yes, this is what you think it is. That's a used roll here. I didn't finish the illustration. That wasn't important. But let's say we had this thing where I could turn these knobs here and just kind of count, like click, 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 and I counted. What would be on the wheel of this odometer registering whatever it is, miles or something? Each wheel in base 10 has a 1, then a 2, then a 3, all the way up to a 9. Notice there's no 10. What I mean by there's no 10 is after you get to 9, you don't stay looking here. This one turns 1, and this becomes a 0. So after 9, because you get 1, 0. So in base 10, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then back to 1, 0. In base 4, the numbers that we're allowed to use are just 0, 1, 2, 3, and 4. So again, I didn't finish the illustration. I just want you to see it ends at 4. So in base 4, it goes 0, 1, 2, 3, 4. Talking about what happens here. After that, you would have 1, 0, 1, 1, 1, 2. After that, you would continue going, but you would not need these extra characters for base 4. We don't even need for base 5 rather. We don't need 5, 6, 7, 8, 9. I think I said base 4 earlier. I'm only talking about base 5. So if I said base 4, that was an error. All right. So in base 5, we need 0 through 4. Just like in base 10, we need 0 through 9. Now this does become an issue in a later problem. Let's say we want to talk about base 12. So in base 12, we can have, let me just get a new sheet of paper here. In base 12, so to a 2-digit number, we can have 1s and 12s. So we can have 0, I'll put a 0 here, 0, 1, 0, 12s. We can have 1, 2, 3, 4, 5. I'm trying to make this kind of look like the wheels that I had earlier with the 0 here. 7, 8, 9. Now it would be incorrect to say 1, 0 in base 12, because remember, base 12 is saying this is the number of 1s and this is the number of 12s. And so in a base more than 10, and I think the only base more than 10 we're going to deal with is 12, but I'm not sure. The website might touch on base 16 or something. But what we need is a symbol for 10. We need to be able to say 0, 10, or 10 1s, 0 12s. I guess with 12s we can think about inches. You don't go after 9 inches, say 1 foot. You say 10 inches, 11 inches, and then 1 foot. So we have these extra symbols, T and E. So what number are we talking about when we say 2TE? It would be 2 in this position. So 2 144s, 10 12s, and 11 1s. And if you just kind of, I don't know, think of that as, I guess you can think of eggs. I don't know. Eggs come in dozens, and I guess they come in, 144 grosses. 12 12s is called a gross. But it's okay to have 11 eggs, and without saying, you get over here and say you have in this next place value, which would be the 12s. I'm not going to do the actual calculation here. I just want you to know how the place value works and the one quirk, and that is, the thing required of us for base 12, because base 10 doesn't have enough symbols for it. So again, T stands for 10 and E stands for 11. And well, let's leave it at that. That is counting in other bases. Oh, I'm sorry. I'm not going to stop there. Let me go ahead and do the same thing I did, but let me do it for base 4. So for base 4, it's going to go a little quicker. We have 1s, and I'm sorry, base 5. There's no base 4 tonight. Start counting. And I'm pausing because something's going to happen. If we're talking about base 5, it's 1 0. 1 1, 1 2, 1 3, 1 4, 2 0. And let me just count this. as if we were actually talking about money, all right? Because I think this is pretty easy. We're removing dimes, and we're only having ones and fives, and I guess eventually 25s. But this would be zero. This would be 1 penny, 2 pennies, 3 pennies, 4 pennies. And then what do? 1 nickel, 0 pennies. 1 nickel, 2 pennies. 1 nickel, 3 pennies. 1 nickel, 4 pennies. And then what do you change it to? You change it to 2 nickels. I need you to be able to picture this, well, with pretty much any base. And I guess at this point I should talk about this process. What I'm doing here with these alternative bases and place value, what we do in this class, it's not for you to bring this particular knowledge back to the classroom. You don't teach young children how to count in base 5 or how to count eggs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you have 1 dozen and 0 extras. Or to count in feet, right? Feet and inches. 9, 10, 11 inches is 1 foot, 0 inches, 1 foot, 2 inches. I guess you could have a short lesson on this, but no, the idea here is we're teaching the concept of base 10, and we're teaching it to students who've never experienced it before, only because they're young and they haven't learned all of the stuff that we learned about our system. So just something like counting and other things we're going to talk about, regrouping, borrowing. I always like to say, you know, can you go one more or one less? So any number in base 5, 2, 0, 1 more would be 2, 1, which is pretty clear, but 1 less would be 1, 4. And again, if you think of it right, as 2 nickels and 0 pennies, what's 1 less than this? It would be, just put them side by side. 1 less than this would be this, and 1 more than this. Do I even have enough nickels? Yeah. Would be this. And just the way we record it, this would be 1, 4, 2, 0, 2, 1. That's what I'm trying to get you to appreciate. In other words, if this makes sense to you, then you know, students relying on these for base 10 should make sense as well. So I want you to appreciate the model and all the time we spend with these models and why they're important. All right, so that is just recording a number, what it means to record a number. I got a little bit into it with 1 more, 1 less, and counting, but you should be able to recognize when the book writes down a number, exactly what it means. All right, we'll continue this on another video.